Session. Anyway, thanks for coming. My name is Tim Rains. I am the security and compliance leader for AWS in EMEA, specifically working on public sector and business acceleration for public sector accounts. So what does that mean? That means I get to travel all over Europe, Middle East, and Africa and talk to public sector, federal, provincial, state, healthcare, all the verticals, national security, and so on, and learn about cybersecurity, what their challenges are, how AWS can help them with those challenges, and so on. And I've done this a long time, so I've learned a lot about how public sector accounts are trying to defend their both on-premises and in-cloud properties and so on. So today I'm going to walk you through some of the strategies that I've learned about over the last 15, 20 years. And then we'll look at one strategy in particular called the Intrusion Kill Chain strategy as an example, and how you can implement that on AWS. All right? Okay, so I've got a ton of content here. We're gonna fly through a lot of this stuff because I do have a lot of stuff here, so I'm just gonna keep it going. And so again, we'll talk a little bit about ingredients for successful strategy. It's not all about strategy. There's a bunch of things that you actually need sort of at the management layer to make all of this stuff work. And then again, I'll walk you through a bunch of strategies, half a dozen strategies at least. And then we'll use an implementation example, the kill chain as I mentioned. And then I'll show you how to get started regardless of which one of these strategies you use or which combination of these strategies you use. Okay? All right, so there's some related sessions here. All three of these happened yesterday, but you'll probably have the opportunity to see them on video at some point. So I recommend looking at these three sessions. There's lots of good security sessions at this particular summit. So you've got some good choices. I'm actually giving a second presentation this afternoon on the Cloud Act. The Cloud Act is a very interesting topic over in Europe right now. Lots of people interested in the Cloud Act. So if you're interested in the Cloud Act, it's this afternoon at 3:50. All right, let's get started. So I mentioned having a strategy is really good. That's actually a great start. A lot of the organizations I talk to, they actually don't have a strategy they can articulate. They have IT initiatives, and they have some cybersecurity stuff that they're putting inside those IT initiatives, but an overarching strategy that they can articulate that describes how they're trying to do what they're doing is actually rare. So having a strategy is good, but there's a bunch of ingredients that will help you with whatever strategy you have, help that be successful. And so you can see here, for instance, alignment with whatever your public sector department or organization, what your goals are, is super important, because we all know for years and years and years, CISOs would approach, Chief Information Security Officers would approach cybersecurity sort of in its purest form, right? They were purists. They would oftentimes tell the businesses that they supported, no, you can't do that because that will lead to a bad outcome or whatever. Those days are almost all gone. You really have to align with the charter of your organization, your company, your public sector organization. Otherwise, there's going to be friction, and the friction's just not healthy and it's not sustainable. So you really need to have alignment between whatever the charter is, the goals, the overarching goals are of the organization, and what your cybersecurity program looks like. Senior executive and board air cover is what I call it, is super important, because I don't know about where you work, but everybody that I talk to has limited resources, right? We live in a world that has limited resources. Those resources have to be divided up amongst all of the people working inside the organization. And so you actually have to work together to be successful in a world like that. And in order to do that, you need the help of the C-suite, the board of directors, and they need to be aligned with what you're doing, okay? Writing down a cybersecurity vision, mission, and imperatives, super important, because that helps you articulate what you're trying to accomplish, right? So the imperatives are sort of like your 3-year goals. And so as you go around your organization to describe your program and how your cybersecurity program is going to work and what it's doing, what it's not doing, right? Goals and non-goals, super important to be able to articulate. Having this stuff written down and making sure that everybody knows that, yeah, the board is aligned with this, the C-suite's aligned with this, that's going to help you get the support that you need across other organizations inside your department or company. All right. Another one I'll highlight here, I won't go through all of these, but high value assets, or what are called crown jewels. Very often I come across organizations that are trying to protect everything. And so they believe their charters to protect everything. And again, we live in a world with limited resources. So your ability to protect all data and all assets, probably not realistic, right? In most organizations, cybersecurity resources are super hard to find. Attracting and retaining top cybersecurity talent, super hard. And so in a world like that, you actually have to understand what your high value assets are. What do I mean by that? I mean, if the confidentiality, integrity, availability of those assets was compromised, the business would fail or the organization would fail. That is a high value asset. So by interviewing the C-suite, by interviewing the board of directors, and then interviewing other senior stakeholders in your organization, hopefully you can get to a place where you understand what the high value assets really are. Because very often people believe, well, it's just all the computers, right? It's all the information worker systems that information workers work on. And that's rarely the case, okay? And all of the data is not a high value asset, right? So even if you're in a regulated industry, let's say you have to do PCI to protect credit card data, okay, you're regulated to do that. You have to do that. That doesn't mean the credit card data is necessarily one of your high value assets. Okay, so there's a difference there, right? You have to identify what assets would make the organization fail if that confidentiality, integrity, and availability was compromised. Super important, because then you can focus on that stuff. It doesn't mean you can ignore everything else, but then you can focus on that and make sure that your program is actually focused on the stuff that really, really matters. And if you have resources that you can put onto other things, other assets outside of that group, that's great. Okay, and again, I won't go through all of this because we will hit some of this. I will hit the very last one on the list, culture, right? Someone recently said that culture eats strategy for breakfast, and that's probably true. In an environment where everybody's trying to help the CISO and their team, that's actually a really positive thing versus everybody kind of just doing their own thing and ignoring the cybersecurity realities of today. So if you actually have the help of everybody within the organization to make some smart choices, smart trust decisions on a daily basis, that can be really helpful. So fostering a culture that is, sympathetic and helpful for the CISO and their organization and what your goals are can be a very powerful tool. All right, so those are some of the high-level ingredients that you need. These, what I'm showing you here, this is what I call like a critical ingredient for success. Okay, in a former life, I owned threat intelligence for the largest software company in the world for a decade. And in that time, we published thousands and thousands of pages of threat intelligence. And I can tell you from publishing all of that threat intelligence, there are 5 ways that organizations get initially compromised. Okay, it makes it sound simple, but it really is true. There are 5 ways that organizations get initially compromised. After that initial compromise, there's all sorts of advanced malware that do novel things and, steal credentials and move laterally and do all sorts of cool things, encrypt data and so on, okay? But in order to get in the environment in the first place, these are the 5 ways that the attackers use and always have, okay? So I call this, this is old wine in new bottles, right? The attackers are using these 5 ways to initially compromise the environment. So anytime you're going to look at a strategy or a combination of strategies for cybersecurity, you should measure them on how they help you address these 5 ways, okay, at a minimum. Okay, the other way I sort of describe this, if you imagine a bell curve, right, a regular bell curve, everyone wants to do the super provocative stuff on the outside of that bell curve. The outside 5%, that's where the advanced threat hunting happens. That's where all of the advanced APT stuff happens. But the middle of that bell curve, okay, that 95% in the middle of that bell curve, that's what these 5 things are. And it's not very, provocative work. This is sort of like the heavy lifting, vulnerability management. Okay, this is real cybersecurity work that's not very sexy, to be polite, right? So, but the hard part is you have to focus on that 95%. If everyone just focuses on the outside, 5%, you're going to miss 95% of what the attackers use to initially compromise that environment. So unpatched vulnerabilities, security misconfigurations, this is what vulnerability management programs address. Okay, and if you look at unpatched vulnerabilities, if you're not on a vulnerability management program, I can tell you from 2016 to 2017, the number of vulnerability disclosures across the entire software industry went up over 125%. Between 2016 and 2018, it went up over 150%. Okay, so vulnerabilities are at an all-time high. Never been more vulnerabilities in the history of the National Vulnerability Database since 1999. Okay, so this stuff's super important. Weak leaks, stolen passwords. Obviously, passwords are still an issue. Multi-factor authentication's helping there. Social engineering by volume. Okay, so if you think about all of the phishing, all of the Trojans, when you think about malware, this is by volume the largest mainstay of attackers, period. This is the secret to their success, the social engineering. Okay, that's not going away anytime soon. And in insider threat, there's kind of two categories there. There's the administrator that makes mistakes that leads to security outcomes, and then there's the, the very small percentage of people that have privileged access to resources that will try to misuse that privilege in some way, and that's, insider threat. So we're going to measure the different strategies I'm going to talk about next based on their ability to look at these 5 things, okay? Help you address these 5 ways that organizations get initially compromised. So let's jump right into the strategies, okay? So there's lots of strategies. Some of you might be sitting out there saying, why is he using that word strategy? That's a really weird word. Like, the kill chain is not a strategy. So my advice is, don't use words like strategy and tactics, because one person's strategy is another person's tactic, and vice versa. When you get someone into a room, like a group of people, and they haven't agreed on what the word strategy and what the word tactic actually means, it's comical, right? It's just comedy. They're like talking across each other. Just don't use those words. You're gonna hear me use them today on stage, but just know that I use them interchangeably. Strategy, framework, model, standards, whatever it is, whatever you want to call that, okay? Just make sure that you agree on that word with the other people that you're working with inside your organization, okay? So you'll hear me call this a strategy today. If you don't think it's a strategy, I agree, it probably isn't. Let's use framework instead. Let's use methodology. Let's use approach. Let's not get stuck on the definition of strategy and tactic, okay? So there's lots and lots of them. I'm going to go through some here that I've seen in use over the last couple of decades. Here's a list of them. So I'll walk you through each one of these very quickly, and we'll use those 5 ways that people initially get compromised as a way to measure, how well these things are going to help you with those five ways that organizations get initially compromised, okay? So let's start with what I call the protect and recover strategy. If you've been to any cybersecurity conferences or events in the industry over the last 20 years, you'll probably have heard of this one called the perimeter security strategy, right? And that's why you're looking at you're looking at a picture of some candy here, okay? It's with the hard outer shell and that soft gooey center. So this is, the typical cliche that we've heard over 20 years. The bad guys, once they get through the firewall, there's nothing preventing them from moving laterally. And once they get to whatever your Active Directory is and they get access to the credentials in that directory and those keys, then recovery is aspirational, right? But when you invest in nothing but this hard outer shell, you're left with the inability to do detection and the inability to do response, because you never gave your cybersecurity teams permission to think about, how would we know if we got compromised? What would we do if we got compromised? The underlying assumption here is you'll be able to do protection so well that you'll never have to invest in detection and response. Okay? And many organizations have gone down this route. Part of the reason why they do that is because they have decades of routing and switching experience and firewall management experience, and they want to leverage that expertise. That makes total sense. But this particular strategy has to be used in combination with other strategies, because if you think of those 5 ways that organizations get initially compromised, this doesn't help mitigate all 5 of those ways, does it? When we turned on the Windows firewall in Windows, when I worked at Microsoft back in Windows XP SP2, the goal of turning on that firewall was to give you more time to patch your system with security updates, because the services listening on the network were completely unprotected. By putting a host-based firewall in front of them, that's going to give you more time to patch those systems. That was the goal. And so if your strategy is to use routing and switching and firewalls, that's fine, but that's really only going to buy you some time, because the flaw in this strategy is that people sitting inside your organization in the course of doing their job are going to go to the internet and bring the badness right through. all of those protections, right? HTTP and HTTPS are the universal firewall bypass protocols, right? Okay, so this one needs help, right? This is still important, and this still can be a useful part of your overall strategy, but it has to be used in combination with other strategies. Another one is the endpoint security strategy. This is what I call a proxy strategy. The idea here is, since endpoints process, transmit, and store data that you're trying to protect, if you protect the endpoint, then by proxy you're protecting the data, right? Okay, so the focus here is actually protecting the endpoints that process data. Part of the drawback of this one is you've got a lot more systems involved than just endpoints when it comes to data, right? You've got routing and switching equipment. You've got all sorts of services that might be involved. Okay, so this one, I mean, it's hard to imagine a world that wouldn't have, endpoint protection. It's hard to imagine an organization that, their strategy wouldn't include endpoint protection. But this one, if you think about how it mitigates those 5 ways that organizations get initially compromised, I would actually give this one a 7 out of 10 when it comes to that. It actually does not a bad job, but it's not complete, right? It can't fully mitigate social engineering. No strategy will fully mitigate social engineering, right? So this one does a pretty good job, but it actually needs some help as well, okay? Compliance is a strategy. So this one I see a lot in regulated industries where they have some sort of industry standard or regulated standard that they have to comply to, okay? And they confuse that with cybersecurity, because they're 2 different things. Proving that you're meeting a standard is different than protecting your high-value assets and doing protection, detection, and response. Those are 2 different things. Sometimes they overlap, okay? Some organizations get confused between those things. They think if they do the compliance stuff, if they comply to that standard, then cybersecurity is taken care of. They get a 2-for, right? Okay, in some cases that might be true. I haven't run into very many organizations that have been successful with that approach, because usually the compliance stuff, that standard applies to a small scope, right? So if you take PCI as an example, that applies to credit card information. What about the rest of the information? What about the rest of the assets in the organization? What about the high value assets? So compliance can be very, very positive for organizations, can get them moving in the right direction. Very often it's required, but very often it's also insufficient to protect you against modern day attackers. And history has taught us over time that this is a poor cybersecurity strategy, right? You actually have to do this, but that's not, that's a starting point, not an ending point, all right? Another one is the application-centric strategy. This is, another proxy strategy where it turns out that applications are being used to process, transmit, and store data. So if you can drive down the number of vulnerabilities, the severity of those vulnerabilities, and make the vulnerabilities that stay in the applications really, really hard, if not impossible to exploit, that's better security. It's going to be much harder for the bad guys to be successful. I really like this one. It doesn't solve all 5 ways that organizations get initially compromised, but certainly if you can drive down the number of vulns, you can drive down the severity of those vulns, and you can make the vulns that are left over impossible to exploit, that's a big part of the unpatched vulnerability component and the misconfiguration component, okay? So I like this one, but again, you have to use this in combination with other strategies. Then there's the identity-centric strategy. Turns out that a lot of bad guys, when they get access to your environment after it's initially compromised, will use identities that they've stolen, right? Leaked, weak or stolen passwords and other types of credentials. They'll use those to move laterally through the environment, picking up more cached credentials along the way, trying to get to the Active Directory, siphon it off, do an offline crack on the weak passwords, and try to get access to more and more credentials. Okay, it turns out that when we do authentication and authorization activities, there's a lot of metadata that's generated. And if we can look and get access to that metadata, maybe we can do interesting things. We can look at the strength of the credential. We can look at the trustworthiness of the system that's being used to do the authentication. We can look at the location the authentication request is coming from and whether that makes any sense. We can use that metadata to make better decisions about whether to authenticate this individual or system, and whether we should authorize them for whatever particular action they're taking, okay? So this one is a newer one, but it's still insufficient to protect us from all 5 of those ways that we get initially compromised. But if you use this in combination with other strategies, this is goodness. All right, another strategy, the data-centric strategy. Instead of using all these proxies, why don't we just protect the data? So a big part of that's encryption. So why don't we just encrypt the data and really just focus on key management, because that's the point of encryption, right? Is to reduce the attack surface area. Instead of having to protect all files everywhere they are forever, you encrypt them and protect the keys. Okay, reduces that attack surface area dramatically. The challenge is most organizations need to share data with trusted third parties, outside PR firms, marketing firms, legal firms. Now you're in a situation where encryption and key management and trading keys with other organizations, well, now we need an identity system. And that was the last one we talked about, the identity-centric system. The part that's hard about that is federation, right? And all your organizations have been grappling with this for 20 years, is how do you give people reasonable access to data and applications in your environment from trusted third parties? And we've gone down this road of ADFS and federated identities and all of these very complicated systems. So in order to get this data-centric strategy to work, you actually need to have an identity-centric strategy in place already. And that turns out to be really hard. So this one is still super important. In the public sector, this is the one that has tons and tons of focus and probably will for decades to come. Okay? Another one is the security clearances strategy. I run into this one in the public sector all the time. Very, very popular strategy. This one is hundreds of years old, right? So we have some information, some data, and that data has been classified. In order for people to get access to that data, they have to be security cleared in order to get access to that data. So in today's world of managed service providers, that means that if you're inside the data center and you have physical access to systems, that means that you have logical access to the operating system, to the hypervisor, to the virtualized workloads, and to the data. Okay? So for years and years, we've had public sector entities demanding that the people inside those data centers have those security clearances. After all, they can get access to data. But what about a world of a modern cloud where we're using encryption, key management, virtualization in combination with each other that actually achieves physical, logical separation of duties, making sure that someone that has physical access to the data center doesn't have logical access to anything? Okay? So this security clearances strategy is still super important in the public sector and always will be, but it has to be used in combination with other strategies because this one's really focused on insider threat. And remember, I talked about two types of insider threat. It doesn't help with the hapless administrator that makes mistakes. It only helps try to get a handle on people that are trustworthy inside the organization and whether they can be bribed. Really, which is really what the focus is of a lot of the security clearances. Okay, so this one needs help from some of the other strategies that we talked about. All right, and then finally the attack-centric strategy. So this is looking at how attackers actually have been attacking, because it turns out that really organized attackers have a playbook. And they've had a playbook for a decade, and they do the same thing all the time. 100% of the time when someone gets into the organization and compromises an environment, within seconds, their scripts are trying to get to that Active Directory and get that file so they can get it offline and do an offline crack on it and get more credentials out of it. Okay, we've seen over and over and over again how quickly these guys move. It's because it's all scripted and it's a playbook. Okay, they do the same things. Now, they might not do them in the same order all the time. They might use different tools. They might have a few different tactics, but frankly, there's 5 ways that they'll initially compromise you, and there's things that they're looking for, like your high-value assets, your credentials, certificates, because once they get access to those, then again, recovery is aspirational. But we can learn a lot by studying the attack patterns that these guys have, and then build a strategy around that. And we're going to go through an example here now. So let's talk about one of those attack-centric strategies, the Intrusion Kill Chain, that was pioneered by Lockheed Martin years and years ago. They wrote a white paper 6, 7, 8 years ago at this point. And if you haven't read that white paper, I mean, I provided the URL here. I think it's required reading for cybersecurity people at this point. But what I describe this strategy is a transitional strategy, okay? If you're trying to move to the cloud, there's certainly a better strategy to use. DevSecOps is where you want to go. CI/CD pipeline making sure that everything that's being deployed meets all of your standards already before it ever gets into deployment. Using things like CloudTrail and CloudWatch to make sure it's constantly in the same configuration in AWS config. Okay? Short-lived environments that you're constantly blowing away and reprovisioning every hour. Okay? There is no place for the bad guys to go in that environment. The hard part is your workforce has to transform, and that doesn't happen overnight. So a strategy like this one that you might already be doing on premise or something close to this can help you if you can translate that into the cloud as well. Okay? So we're going to go through this, but essentially what a kill chain is the 5 or 6 or 7, there's lots of different variations of it, but the steps that the bad guys take to attack you. Starting, for instance, with reconnaissance that you can see here. In this phase, they're trying to decide, who am I going to attack? What hardware and software are they running? What does their IP address space look like? Okay? They're trying to do reconnaissance on who they're going to attack. The next one is, now that I know that they use, for instance, some PDF reader that has lots of publicly disclosed vulnerabilities, I'm going to weaponize that. I'm going to weaponize a malformed PDF file. And when I get that to them and they open it, if they're not fully patched for those vulnerabilities, then I'm going to be able to download more malware to that system. So they build a weapon. Now they have to figure out how to deliver that weapon. Is it going to be via email? Is it going to be via USB drives? Which one of those 5 ways that organizations that initially get compromised are they going to use to deliver that weapon? That's what they decide in this phase. Once they deliver it, when the person double clicks on the malformed PDF as an example, then exploitation happens, right? So now if you're not patched for the vulnerabilities that they're trying to exploit, you actually get exploited. Now they have privileged access to that system and the ability to do, a range of things, including running arbitrary code in some cases. Then installation, now they're going to download more malware, or they're going to unpack it from the original file, install it on the system so they can remote control it. C2 is command and control. So now they're going to use this network for whatever their motivations are, right? Is it profit? Is it destruction? And everywhere in between that. And then finally, actions on objectives, right? So what are they doing? Are they siphoning off data? Are they just trying to stay there and watch what's happening? What are they doing? Okay, that is the kill chain. Okay, now in Lockheed Martin's paper that they wrote, they describe building this courses of action matrix. So for every single one of those phases, we are going to detect, deny, disrupt, degrade, deceive, and destroy the bad guys in every phase. So all of a sudden, you can see here that instead of the bad guys, for instance, if we go back to the protect and recover strategy, which if the bad guys get through that firewall, and through, even if you're doing microsegmentation, if someone inside the organization brings them right through the firewall, you're done. Your strategy's over. It didn't help. In this case, the bad guys are going to have to be successful and or lucky multiple times. Now, it doesn't matter if the bad guys go through all 7 of these steps. It doesn't matter. They're going to have to go through at least one of them. So if you put capabilities in each one of the areas in this matrix, that's going to make their job a lot harder. That's what this strategy is all about, is raising the amount of effort it's going to take for them to be successful and lower the return on investment. They're going to invest much, much more effort, time, and energy to compromise a network like this than some of the other strategies that we looked at. Okay? So what I did is we built a kill chain strategy, if you will, for a cloud environment. And in order to do that, I did a couple of things. I changed the courses of action matrix in a couple of ways. Reconnaissance, I broke into 2 different phases, pre-intrusion, post-intrusion. Because the tools you're going to use to determine whether someone's doing reconnaissance on you before you get attacked, and then the tools that they use once they get into your environment and they start doing reconnaissance, looking at what your environment looks like where the crown jewels are, where the SCADA systems are, where the data is, those tools will be different. So the ways that you deny, deceive, and so on between those 2 types of reconnaissance can be different. So I broke them apart. The other thing I did is I removed destroy, because most organizations don't have a charter or ability to destroy their adversaries, really. And I replaced it with some things that actually the cloud is really, really good at. So contain, once the bad guys get into your environment using one of those 5 ways that they initially compromise the environment, you're going to make it super hard for them to move laterally in that environment. That's what contain is. Respond if things go wrong and they get in the environment, we want to have a response plan already. We want to have response capabilities already, okay? Because what we're trying to do is reduce the amount of time between the time that they actually compromise the environment and the time that we actually stop them, because that reduces the damage and it reduces the cost, okay? And then finally, if everything goes wrong, restore. If they get through the entire kill chain and you're left to clean up the mess, being able to restore your infrastructure and restore your data back to where it was before as quickly as possible minimizes the cost. So you want to have restore capabilities already planned out. All right, so I'm going to walk you through an example of the kill chain for exploitation. So in this scenario, the bad guys have already figured out that they're attacking me. They figure out that I use, let's say, a malformed, or I use a PDF reader. They're going to send me a malformed PDF, and they're going to try to get me to double click on that PDF out of an email. And when I do, it will try to exploit a vulnerability on my system that's not been patched. Okay? So we're going to walk through exploitation. So right now we're going to detect exploitation in that scenario. So I'm not going to walk you through this because we don't have 6 hours, but I will pick one example off each one of these slides. So for instance, the top one, Amazon Guard Duty. This is a great detection tool, right? What Amazon Guard Duty is doing is it's using VPC flow logs, so all the network traffic going in and out of your VPCs. It's using DNS logs, and it's using machine learning to go through a massive amount of logs, including the CloudTrail API logs, to go through all of that in a way that humans would take much, much longer, right? So it's using machine learning to go through that and identifying indicators of compromise. Like someone's doing Bitcoin mining, someone's talking to known command and control infrastructure, someone's talking to Tor networks. Okay, so that's what it detects. This can help us do detection on exploitation as well, okay? So in deny, now we have a bunch of tools here in AWS that can help us deny exploitation. So an example here would be IAM, Identity Access Management. Here we have a thing that you're probably familiar with already, roles, right? So instead of having long life credentials that once I give you a username and password, that username and password is in use for 90 days. Now, when someone goes to get access to a resource, and they do it via a role, they have access for like 15 minutes. So in terms of exploitation, if that user credential only has access for 15 minutes, it makes it much harder for the bad guy then to break out and do things in an environment like that. It limits the blast radius, as we like to say at AWS. Disrupt. So the way to lower the ROI for attackers is to make their attacks, even if they're successful, inconsistent. So that let's say they do have a PDF, a malformed PDF that can exploit an unpatched vulnerability. What we're going to do is make sure that it will only be successful once every 255 times that they run it. So for example, down at the bottom of the list, ASLR, Address Space Layout Randomization. This is built into Windows, it's built into Linux. This makes sure that that memory address that they're relying on that vulnerability to be at is different on every single machine, because every time they reboot the machine, the address gets randomized for that service. So it makes it much harder for them to be successful, and it can disrupt attacks as well. Degrade and deceive. So degrade, again, we're trying to make it inconsistent. We're trying to make their attack less successful, right? So for instance, great combination, Amazon Guard Duty and AWS Lambda. Now Guard Duty is giving you indicators of compromise. It's sending you alerts saying, hey, we're seeing indicators of compromise. You can put that together with serverless like Lambda and let Lambda go and do a bunch of things as a result. Okay, and I'll walk you through an example of what that looks like here in a second. Deceive. I'm a big believer in deception technology. If you haven't checked out deception tech, you got to do it. Deception tech can be a very, very powerful cornerstone of a cybersecurity strategy. Deception tech can help you with insider threat. Deception tech can help you if your infrastructure's already been compromised. Okay, so deception tech, what you're doing is you're putting infrastructure out there with lots of low-hanging fruit to attract the bad guys. Unpatched vulnerabilities, you're putting in their credentials that are easy to steal. And when those credentials get used anywhere else in the environment, you know they're there. If someone goes to that system and exploits those vulnerabilities, you know they're there. Okay, that's what it's there for. It's a canary, right? A canary in the coal mine. So that's very, very powerful. You can do that. We've got partners that do deception tech in the AWS environment. And then contain. Here I'll use, I don't know, let's say, service control policies, okay, SCPs. Service control policies define who can do what to what service, when, what time of day. So for instance, I can say, you can only log into a system and run this service Monday to Friday, 9 to 5. So that makes it much harder for the bad guys to take advantage of that service if it's only available for those 8 hours of the day, primarily when other people are using it, okay? As an example. All right, respond. So here's a bunch of response capabilities, of course, just a subset. Guard duties, great, has some great partners that you can use in conjunction with guard duty. So if you go check it out, there's actually a partner page for guard duty that'll walk you through all the partners that have capabilities that have been integrated into guard duty that will help you in a response scenario. But there's tons of tools here. And then restore, I'll use auto scaling as a great example. So, and most people don't think about patching in this way, but because we've been trained over the years that we have to scan for vulnerable systems in our environment using, 20-year-old protocols, or put a half a dozen agents on the system and rely on those agents to help us find the system and determine if they're vulnerable. Imagine if all I have to do is patch my gold image, and then I just start shutting down servers, what happens? Auto scaling sees, hey, you don't have enough servers provisioned for the load that we're under, and it starts building new systems using that gold image that you just patched. So that means every image is always going to be patched. No applause. Okay, so we're moving on. All right, so now let's measure performance. This is what I really love about this strategy, is how to measure performance. You're going to do intrusion reconstructions to understand how your approach is performing with the bad guys, right? So what you're trying to do with an intrusion reconstruction is figure out, how did the bad guys not get stopped in phase 1, 2, or 3? Like, how did they get to the exploitation phase? How did they get past all the capability that they already invested in at the top of that kill chain? And then once you determine that, then you can figure out which of your vendors are not working the way you thought it would, which of the integrations are not working the way they should be. Okay, there's all sorts of things that you can learn from this. And you can figure out which controls you're going to replace because they're not working the way they should, which vendors, when their contract comes up, you're not going to renew with them because the stuff doesn't work as advertised. You can then look at where the gaps are in your strategy, and you can tell the board and tell the C-suite, look, we know we have a gap in exploitation because the last 5 intrusion attempts, the bad guys have got right to that point. So we need that extra budget in order to invest in that gap. And that's the kind of data that boards and C-suite people pay attention to because it's data driven, okay? Then building blocks, how do you get started? Well, let me give you some examples here. Regardless of which strategy you're picking or which combination of strategies you want to use, there's lots of good building blocks inside of AWS. So the sources of information that you have in AWS are typically much, much better than what you've been dealing with on premise, because you got to remember that everything in AWS, it's all API driven. Okay, so that means regardless of how you interact with AWS, whether it's through the console in the browser, whether it's through the command line interface running scripts or manual commands, or whether it's through an application that you wrote with an SDK that interacts with AWS, it all goes through APIs. So that means if you have this one place where every command actually goes through, why don't you just watch that and control things that go through there? If you see something you don't like, take action on it in near real time. So this central API is a game changer for security and compliance people, okay? The other thing is you've got CloudTrail is where the APIs get logged. So if you're not familiar with CloudTrail, you need to check it out because that's the service where we're constantly logging API calls for you. But then you have VPC flow logs, it's all the network traffic. CloudWatch logs, this is essentially your SIM in the cloud, right? Where you can actually stream events from your environment, pick out metrics, and then decide which metrics you want to alert on and event on. And then you can take a range of actions. I'll show you an example in a second. And then DNS logs. DNS can be a very rich source of information on who's querying what the queries look like, and so on. All right, here's an example of Amazon Guard Duty going through an entire life cycle of an attack, just showing you the types of things that it does to detect Again, indicators of compromise and what's actually happening. So using ML across all of those logs is super, super powerful. And guard duty is designed to actually cost you less than 1% of your total AWS spend. What I tell my customers to do all the time is turn guard duty on in every region in the world. You're probably not thinking about doing business, let's say, out of the US. So if you turn guard duty on in London, France, Germany, Sweden, and anything ever happens in one of those areas, guard duty is going to tell you. And it doesn't cost you anything until it tells you something, right? Okay, so it's a no-brainer. You need to turn on guard duty for detection. All right, AWS config rules. Imagine you get to decide how every EC2 image, how every service you use is configured right from default. If it ever strays out of that configuration, you can take action. What do you want to do? Do you want to just alert somebody like the compliance team or the server team or whoever you have that's worried about configuration? Or do you want it to automatically bring it back into configuration in near real time? That's what AWS config rules actually do. And then CloudWatch, I mentioned CloudWatch events will help you take action based on the metrics that you've been streaming into it. So these are very powerful tools that will help you always stay compliant with whatever that standard is that you care about, and always help you understand whether the bad guys are taking advantage of misconfigured systems or trying to do exploitation on the platform. There's lots of uses for these. So let's walk through an example here. We talked a little bit about CloudWatch. I mentioned Lambda already, so serverless computing. This is what we're gonna use to take and do things with our triggers. And then Systems Manager is very powerful because, for instance, with vulnerabilities, you could patch your whole fleet using Systems Manager inside the cloud. And the Systems Manager agent, you can actually run it on-prem if you want to as well. So very powerful set of tools here. So in this example, guard duty detects exploitation happening on a system inside of our VPC. When it goes and looks, it determines, yeah, there's an unpatched vulnerability on that system. It hasn't been patched. So what it can do is it can actually work with Lambda, for instance, and say, Lambda, I want you to go automatically go patch all of the systems that are missing that particular patch. And remember, this is happening in near real time. There's not 50 people inside of a security operations center trying to figure this out with all of these queries, right? This is happening using machine learning, okay? The other thing it's doing is it's saying, hey, when we have a compromise like this, take a snapshot of the storage, send email to our forensics team, and tell them to come and set up the forensic software and start to analyze this and see what actually happened. Again, in real time, automatically, because it's actually happening via Lambda and some of these other tools that you see here. Okay? Another example. All of these log sources that you see here, we talked about them already. CloudTrail for the API, the VPC network flow logs, the guard duty findings, Amazon Macy's, all about tracking data that's been classified, where it's moving in the cloud and so on. It's getting all of this data and streaming it to CloudWatch events. In this case, when CloudWatch events see something that's interesting to us, how do we know that? You define that, right? You define what's interesting to you and your organization based on your high value assets and the threats that you care about. Lambda can take action. In this case, Lambda is communicating with your teams, your incident response team and so on, using whatever channels you use, for instance, Slack or Office or whatever it is. And because AWS is API driven, it's able to go and change settings on all of the services if that's what you needed to do. You can take a whole range of actions here. All right, where to start? The Cloud Adoption Framework is a great place to start. This will show you what order to start doing things in. It makes sense to do identity first because you can't do authentication and authorization and do privileged access to resources without identity, right? The next thing to look at is detective control. The next thing, infrastructure. So check out, if you haven't looked at the Cloud Adoption Framework, there's a security perspective here that you should check out because this will help you get started on whatever strategy it is that you pick if you choose to implement that in AWS. Okay, and then finally, there's a well-architected review. So we have a white paper, we have partners that do well-architected reviews, we actually have a well-architected tool up on the website that you can use for free. When you do your architecture, a well-architected review will walk you through the principles, the security principles that you need to pay attention to in that design and make sure that you're doing Amazon best practices in that architecture. Okay? And with that, I hope that was fun. Thank you.